Good evening, ma'am.
Hi, Nafa.
Hi, ma'am.
Shall we start? I don't think anyone
I
else is
don't think
joining.
anyone else is joining. Okay, ma'am.
So, have you solved
So
this
have you
assignment?
solved this code?
Have you solved
Ma'am,
this?
I already solved. I have solved it, but I don't know if it's right, ma'am. It's just like I'm not sure with my answers.
One second. Okay. So this. So today's assignment is mostly about. This is first week assignment, and this is mostly about to determine the point group of the molecules, right? So I told you in the last class how do we decide the point group. Like we bifurcate and we like for we check for each symmetry element, and if that element is not present, we move ahead to check for the higher symmetry element. So for this point group, so you can think of this molecule as nitrogen connected to some R group. I will write this as R. Okay. And since nitrogen will have a lone pair of electron, right? This is slightly, just imagine it as NH3, but here it's not simply H. R is a complex molecule which has its own symmetry. Now this will have a lone pair. So eventually it will become something like this. Okay. So this is just for representation purpose. I'm not saying the angle and all is exactly 109. That I don't know. So that is not necessary also. Okay. Now, so what you will think, this molecule which looks like ammonia, it should have which axis of rotation?
Ma'am, C3.
C3. So let's first
C3.
check.
So let's first check.
So C3. Okay. And this is lone pair. So if I make a C3 like this, C3 will go through this nitrogen atom, right? Like that. Okay, my axes are like this. Okay, so this is C. You can imagine it like this arrow is piercing nitrogen atom and coming up. Okay, then imagine the C3 is there, so it means rotation by 360 by 3, that is 120 degrees. Now if you rotate it by 120 degree, what will you get? Now instead of R, just make sure that you have a benzene molecule here. But the good thing is that all the atoms in this molecule are chlorine. Like all the side atoms are chlorine. So that part is symmetrical in itself. We don't have to worry about that. Now think of a rotation. So this bond which is shown by dark lines, So this dark line, when I rotate this by 120 degree, won't it be like this? Right? And the other 120 degree rotation, it will generate this one. So by the way, what does this dark and light bonds mean?
I'm not sure.
So this means that this part of the plane is up. Okay. How do you can imagine, you must have seen this ceiling fan, right? If the ceiling fan, the blades will be not parallel to the floor but perpendicular to the floor or the ceiling. How will it look?
Got it, ma'am.
Right? So it's like that. The planes are not parallel to the ceiling. It's like it is perpendicular. So when you, not exactly perpendicular but at some angle, so this side of the, these three bonds are tilted upwards and the other three are tilted down, right? It's like slanted. Now when you will rotate this slanting part will come over here. So this part will get exactly replicated even after 120 degree rotation, right? So this molecule will have a C3 axis. So 3C3Z is confirmed. Now, so you see the options are D, C, D and C. Now, how do we distinguish between C and D is, if C3 is present, so obviously the highest principal axis is C3. There is no C4 because it's like three bonds are there, right? If you rotate it by C4 means 90 degree. 90 degree rotation will, sorry, okay, this is like that. So if you go for higher principal axis, suppose C4 rotation, then it will do it something like this. So it will change the molecule. So this is not same as that. So C4 is not there. Okay. So we have got that the highest principal axis is C3. Now out of, now to distinguish between C point group and D point group, we will have to look for perpendicular plane, perpendicular axis. Now we have found that Z is the principal one. Okay, then you look for whether it has perpendicular C2s. How do we check that? Wait, I will show you something, you'll understand. Can you see this molecule? So you think of this orange center bond as nitrogen. Okay, and imagine that the other ones are your this benzene ring with 5 chlorine atoms. This is just for representation, this is not the same molecule, but you can think of that, just think that this is the R group. Now what I told, that suppose if you look from this angle, this bond, where is, do I get pointer here? Okay, can you see the mouse cursor?
No, ma'am.
No. Okay, fine.
Okay,
Uh,
fine.
Fine. From this angle, what do you see? That this top red bond is upright, right? And the other one is down.
Yes,
So
ma'am.
I'm talking
So
about the
I'm talking
top
about.
one, which I'm trying to rotate. See, this is on the top, right? And the other one is behind it. Okay. So this
Okay.
is this
Yes.
is
So
what I meant
this
by
is.
that this bond is the dashed one is on the top. I told you, na, it is like slanted blade of the fan, like that. Now, what? How do we have to check for C3? C3 we looked at it has a C3. Now, see where does the C3 is coming from? The central atom where the C3 line is going is our nitrogen atom for that molecule. Can you see this?
Yes, ma'am.
Now, let us try to rotate it. So you saw that the top bonds are always coming at the top part. I will do it again.
Yes, ma'am.
Okay. So C3 is there. Now we have to check for perpendicular C2s. So let's say C2. Now you see where is the C2 coming from. It will pass through one of those rings and the nitrogen atoms. Okay. So instead of this five membered
Instead
ring,
of this five.
imagine here you have a six membered ring, like the benzene ring for your question, like the molecule in question. So this C2 is there. Now you check for its rotation. Fine. We don't have to worry about all the side atoms because all the side atoms are chlorine here. So they will get interchange if everything is chlorine. Now look for, now how many rings we have? We have three rings. So it will have C2 passing through all the three rings. So this will be another C2 through this ring, and there will be one more C2 through this ring. Understood?
Yes, ma'am.
So you have three perpendicular C2s. Three perpendicular C2. Now, what are the options now? So we have found that C2 is perpendicular, C2 is there. So it cannot be a C point group is not there. Okay. If principal axis is present, then we look for perpendicular C2 axis. If it is present, then it is a D point group. If it is not present, then it will be C or S point group, like that. So we have confirmed that this, since perpendicular C2s are present, it is a D point group. Now out of D and out of these two, now we have to we have to check if it is only D3 or it is D3V. Now the difference between D3 and D3V is what?
Like in D3V, there will be a vertical, like sigma V will be present,
Sigma.
and D3
So
will.
yeah, so we have to look for sigma planes. Now let's check. Suppose here itself So since this molecule is not having a sigma plane, but imagine that instead of this axis, it is a plane. What will it do?
What will it do? They don't look identical, right? Like,
Yeah, it doesn't have.
yeah, it doesn't have. Yeah. Okay, ma'am.
Yeah, it doesn't have. That's what I mean to say, that that this molecule does not have a plane, because since there is a orientation, up and down orientation in this one, so you see the plane has to pass through this. So you see, if, okay, I will draw it, it will be clear. If this is the benzene ring, this is like this is upright, okay, then the other bonds are like this way up, and this one is this way up. Fine. So if I have a plane which passes through this bond, so it contains this upright bond, and the N atom. Okay, it contains this benzene ring is in the plane, this red plane. Now, how will these two will get reflected? So it will be something like, these two are not getting reflected, right? Because here this one is upside, the mirror image should have been like this, right?
Yes, ma'am.
But it's not the case. It is changing the angle, like the tilt of the molecule is getting changed here. So sigma plane is not present. It is true for all the three benzene rings. If you put that plane containing any of the three rings, the same situation will happen. It has a directionality, okay? It, if you turn this, it comes over here, then it has a directionality, but it doesn't has this mirror image thing that a plane will do. So sigma planes are not present. No sigma v. Now what is the point group then? So out of D3V, in D3 V is not present, so the point group is D3. And you could have also checked for H. H means what? Molecular plane. Molecular plane, sigma H. So what a molecular plane is? It contains the maximum number of atoms and bonds within the molecule, and it should be perpendicular to the principal axis. It is not any ordinary plane. It molecular plane sigma H, it should be perpendicular to, principal axis. Okay, so it should be like this. If this is your molecular plane which contains the molecule, then your principal axis should be like this. Understood? So you see this molecule. Okay, you see this example again. So where is the C3? Now C3 is going like this. So C3 is, it's like uh, going from top to bottom on the plane of your notebook or your tab, whatever you are using. So it's piercing that plane. Now perpendicular to that plane will be the plane of your paper. So can you put the molecules like that? And they should reflect also. Since it's a plane should reflect. But if you put that plane here, I will draw exactly like this. Okay, now see, if you, so this is your, can you see this? This is C3, right?
Yes, ma'am.
Then a plane should be like this, which should contain this ring completely. This ring completely should be there in the plane. But can you reflect this ring and this ring?
No, ma'am.
No, they are at different spatial location. They are not exactly on top and bottom, right? If you imagine this side, this ring is on this side of the plane and this ring is on this side. They are not overlapping in the z axis, in the z direction. They are not top and bottom of each other, so they will not reflect anytime. So sigma h is not present. So the point group can not be D3V or C3V or C3H. C3 is there and perpendicular C2 is there, so it is D3. You can have a look on D3. What are the other D3 molecule? This is a similar type of molecule. This, it has 5-membered ring, but yeah, this is a good example. So instead of that so instead of this 5-membered ring, you have a 6-membered ring which is connected by a single bond, and the other, these white balls, instead of that you have chlorine, single chlorine, because that's a double bond for us. Okay, so coming to the next question, what are the symmetry elements present in this molecule? Now this is, how can we represent this? What do we call this kind of conformation?
Not sure, ma'am.
Isn't this called
Isn't
chair?
this called chair? I haven't really studied it yet. Maybe that's why I don't know.
Okay, fine, fine.
Okay, fine.
So you this is what's it's just a cyclohexane. This portion is cyclohexane. Okay, so I'm just denoting it in regular notations like that. And these are the axial bonds, these are also axial bonds, but this one is on top, this is down, like in going downwards. Okay, so let us first name these. So let us name this carbon 1, 2, 3, 4, 5, 6. You agree that there are 6 carbon?
Yes,
Now
ma'am.
this, so carbon 1 contains, let us name it here as well, 1, 2, 3, 4, 5, 6. So carbon 1 contains a chlorine molecule which is on top. So here I will put this notation, dash wedge notation. Are you familiar of this notation, wedges and dash?
Yes, ma'am.
Okay, so what does this mean? That it is on upside, right? Up from the plane of the paper.
Yes, ma'am.
Now so carbon 1 is done. Then here we have Cl, here we had Br, here Cl, here Br. Okay. So now come to carbon 3. It contains a bromine which is also on upside. Now then fourth number is Cl, which is down. So down I'm denoting it like this, dash. And sixth one is again a Br. Okay, now can you find all these symmetry elements in this representation? Now check for C2.
Ma'am, I'm not able to find C2 on this.
Okay, let us do it. Okay, start from the easiest one. Look for this I.
I think I is there, ma'am.
Yes, you can easily visualize it in like this.
Yes.
So this PR is top, this PR is down. So when you will pass it through here, you will find this same group on this side. And the other atoms are hydrogen, hydrogen. So you don't have to worry about it. They are there. Okay. Now if you move for this chlorine, you will find this chlorine here. So the I is there. I is in between molecule. I is here. So I is present. Now C2. Okay, let us check for C2. C2 XYZ. Start from C2. Let us start from C2Z. Now if C2Z is there, how will it get rotated? Like this, right? Is it correct?
Uh, ma'am, it's not correct, right?
C2C. Yeah, it's
C2C. Yeah, it's
this
this
top part will come here.
will
This
come here.
top.
Pop. Then that part should be like pointing downwards, right?
It's just 360
It's
degree,
just 360
180-degree
degree
rotation.
180 rotation. Okay. Okay, ma'am. Yeah, fine. Got it.
We are not reflecting.
We
It
are
is
not reflecting.
plane.
It is.
This is
Okay.
axis.
X.
Fine. Then
Then
let us name these atoms. Again, what was this? This is 1. This is 3. So here this is 5. And this is 2. This is 1. 1, 2, 3, 4, 5, 6. So the 1 will have a chlorine which will stay on top. 3 will have a bromine which will stay on top. 6 is a bromine downwards and 4 is a chlorine downwards. So the up-down orientation of these bonds, axial, did not change, but their position got changed. These two are
yes,
not
ma'am. These two
identical
are
or
not.
equivalent structures. So C to Z is not present here. Okay, you can look for C2X. Obviously X is not there because X will flip it and the up bonds will X will be like this. How will it change after that?
Whatever is on top will come down.
Yeah. So
Yeah.
this will come up. Something like that. Very bad drawing. Like this. So this one is 2. This is 1. This is 3. This is 4. This is 5. This is 6. So now these bonds have also changed. So this CL was top, now this will be down. This BR was top, this will be down. And these two, 4 CL will be, it will become like this. So this is also not equivalent. So C2X is not present. Now you can imagine the C2Y is also not there. The C2Y will have to pass it like
Yes,
this.
ma'am.
Like this. So it has to flip around this. This part, this side will go on this side. So this orientation will not change. Okay, but this will become 1, this will become 2, this is 3, this is 4, this is 5, this is 6. This is for C2X, this is for C2Y. Okay,
Okay, ma'am.
now what will happen to the bonds? On 4, Cl is down, so if you flip it around this direction, it will become up. And 6, Br is down. On flipping, it should become up. No, no, no. So if I have flipped it, 1 will go in the place of 6. This will come over here. So this bond will have a PR which is down. Sides will not change. So this will be a Cl, this will be a Br, and this will be a Br, and this will be a Cl. Are you able to imagine now, Fa?
It's a bit difficult.
I'll draw it again. Wait.
I'll draw it again. Wait.
Okay, just for for now, forget the numbering and think that you have an axis over here, and you have to flip this molecule around this axis. Okay, you have to, so you have to flip like this, out of plane
Okay, ma'am.
rotation. Out of plane rotation. It's not that it is not
Not
moving in
that
the
it is
plane.
not
So
moving
suppose
in the
if you,
plane. Yes.
so this was C2Z, no? C2Z, what we did, we in the same plane, imagine uh, in the same plane you
In
just
the same
rotating
plane, you
it
just
like this.
yes,
But here
yes.
what you have
But
to do,
here, what you have to do
around this axis you have to
around this
flip it.
axis, you have to
Out
it.
of plane you have to flip
Out
it.
of plane, you have to flip it. Yes, ma'am.
So how will it become then?
How will it become then?
Now numbering 1,
Numbering
2,
one,
3,
two, three,
4, 5, 6.
five, six.
Now if I have flipped it,
If I flip it,
the orientation will not change this time.
Yes, ma'am.
Fine.
Fine.
But this
But
atom, imagine
this
where this atom will
imagine
go.
where
This
this
Cl
slogan will go
should come
here
over here,
should come up here. Yes, ma'am.
right? And but
Right?
since it was up, it will go down here.
Yes, ma'am.
Same case, this Br, this Br was here. But since it was down, so imagine this Br going all the way from this side to up. So it will go up. Okay, and this Br which was up, it will come over here, right? But since it was up, it will be down here. And this Cl will go over here in place of this. So here. And since it was down, after rotation, it will be on the top side. But not, this is
Yes.
not
This is
equivalent. This is not equivalent configuration. So sigma
yes, ma'am.
C2 ZXY not present. What is left now? Sigma D. Sigma D. Sigma D is what? A plane which will be
Plane.
parallel to, which will be perpendicular to your principal axis, and it should cut two C2 axis. It should bisect two C2 axis. So such plane is also not present since you don't have C2s here, first of all.
Yes, ma'am.
So you can simply imagine planes like this. Now same as C2, suppose you have a Z plane. How will it change?
The mirror images are not present.
Yeah, mirror image is not
Yeah.
present. So if you rotate it, reflect it around this plane, this side, this point which is going like this, it will go like this.
Yes, ma'am.
So it will change. So this is not mirror image. So you can see this is bottom, this is top. Even if you put a plane, the plane is not there because for this had to match, it should have been like this. If something was like this, then we can think of putting a plane here which would have reflected.
Yes.
So sigma planes are not present. Sigma d simply means dihedral plane. If you have multiple sigma v's, so those sigmas which bisect two C2s are called dihedral plane. It is simply a sigma v bisecting. Bisecting means it exists between two C2s, C2 axes. It's just nomenclature. You can just think of it as sigma v only. So that
Okay.
also is not present. So we have neglected these options are ruled out. Only I is present for this molecule. What about this one? The molecule that has an S6 symmetry element. How will you figure out S6?
And we have to rotate it by C3 and then reflect it to perpendicular to the axis.
No, it is S6. So you have to rotate it by C6 only.
Oh, okay, ma'am. Yeah, sorry. C6.
C6 and then perpendicular plane.
Yes.
So it should have six symmetric thing. Now all these molecules, let us rule out the molecules first. So something which is like pH 5, it will not have a C6 axis. First of all, pH 5, how does it look?
Trigonal bipyramidal.
Yes, trigonal
Yes.
bipyramidal. And these bonds are like this. So it does not have a C6 symmetry. It has C3. Okay, C3 is there, then C6 is also there. C6 means 360 by 6, which is 60 degree. But if I turn it by 60 degree, 1, 2, 3, 60 degree will make it like 60 degree will make it like this, I guess. How much? This one is 120. This is 180. 60 degree will change its orientation. Just figuring out where. I think it will become like this. This much. Imagine this H1 was here and now H1 is here. So if this angle is 60 degree, it will become like this.
Okay,
H1,
ma'am.
H3 and H2. And you have these H4, H5 which are, so C6 is not present here because this orientation got changed. Wait, I'll show you. So this is PCl5 molecule, but similar will be the structure for pH3. It will be like this. So these planes are your equatorial, and this is axial 4 and 5. But C6 is not there. Even if you have a sigma plane which will reflect it, C6 is not present, so S6 is not present.
Yes,
You
ma'am.
understood where is the sigma plane? This equatorial bond plainly is the sigma plane.
Yes.
But we don't have the principal axis as C6. C6 is not present. Principal axis is C3 only. Principal axis is C3. So it can have S3 but not S6. Right? So this got ruled out. Now CH4. What is the symmetry for CH4?
Tetrahedral.
Tetrahedral. Tetrahedral is very symmetric. A tetrahedral molecule, tetrahedral TD, like a methane, CH4, methane. Now look for C3 is there. It will pass through the central carbon atom and one of the CH bonds. Let me show one C3. Okay, this is the C3.
Yes, ma'am.
But what do we need? We need C6. But C6 is not there. So it's
Yes,
120
ma'am.
degree, but for C6 what we need 60 degree. But if you keep it 60 degree, the rotation should stop in between. But that will change the structure. That will not be equivalent structure. So for TD also C3 is present, not C6. So S6 is not present. And also you need to have perpendicular sigmas, but here there is no perpendicular sigma v. All these planes are parallel to the C3 axis. Okay, look at this. So you see this plane and the axis. The plane contains the C3 axis. It is not perpendicular, it is parallel. So we for S improper symmetry element we need to have a perpendicular C3. Perpendicular sigma plane. But all these will be parallel to the, these are, I was telling you about dihedral sigmas, no? So here you see you will find dihedral. Let me show you two sigmas. So now there are three C3s, right? Passing through four C3s, passing through
Yes, ma'am.
all the CH bonds. Okay, now I will show you how the bond sigma plane passes. Now you see this sigma plane. It contains two C2 axes, but it also bisects like two C2 axes. It is in between two
It is in
C3
between
axis. Sorry.
two C3 axes. Sorry. Ma'am, but dihedral plane should be in between C2 only, right?
No, dihedral plane means
Dihedral plane means
between
between
between the
between the
cutting the two C axes.
C axis. Oh, so it can be of any n value.
Yeah,
Yeah. Okay.
it also cuts, but this one, yeah, it also cuts 2C2 here. No, no, it cannot be of any
No, it
n
cannot be
value.
of
It
any
has to be
value.
C2,
It has to be
between two
C2.
C2.
Between two C2.
Here
Okay, ma'am.
C2s are there. I
Yes,
did not
C2s
see
are
them.
there.
So these C2s are there. This is sigma t. So this sigma plane is always bisecting two. 1, 2, 3. 1, 2, 3 is containing the all the CH bond. These planes are containing all the CH bond, and this one is containing two CH bonds. So there is a difference. Can you see that?
Yes, ma'am.
This plane is containing two CH bond. Okay, but
Yeah.
this plane is containing, or this also is containing two CH bond, but they are at an angle.
Got it.
Each parallel to a C2, and then where does the other sigma d is coming from? The other one will be, so out of four bonds, it is taking two at once. So it is like 4C2 combination. So it should have six, yes, 4C2 combination. It will have six planes. So yeah, so our conclusion was that it does not has a C6. So CS6 is not there. Now next one was, this is tetrahedral. Now come to B2H6. What is the structure for B2H6? What is this molecule famous for?
The banana bond.
Yeah, the banana bond. Okay, now this is, these BH, these are on the plane of the paper. Okay, Now this one
Yes.
is
So this one
facing up top and this is facing down. Okay.
yes, ma'am.
What is the name of this molecule?
Diborane.
Right. Diborane. Diborane is famous for having D2H point group. Now let us see how. First one is we will look for the principal axis. What is the principal axis? Let us start from 4 because it has 4 atoms in plane. Let us start from 4. So does it have C4?
Yes, ma'am.
Where? C4 means
C4 means
if you pass this
if you pass
C4
this
axis
C
here,
here,
means it should rotate
means it
in
should
case
rotate.
the plane is like this, it should rotate 90 degree. If this is a rectangle,
If this
suppose
is a
this is a
rectangle,
rectangle,
suppose this
the
oh, I
rectangle
have
has to
the
come like
rectangle
this
has
in
to
the
come
plane.
like plane. Yeah.
So this B atom will
This
go
B
here,
atom will
H will come here,
come here,
H will come here, and B will
come
come
here,
here.
and B will come. Okay, ma'am. So
Right.
it does not have C4.
So it is
So
not
it is
present.
not present. Yes.
Now look for
Now
C3.
look for C3. C3 also will not be there right now.
So where do you look? Where will you look for C3? Is you look for C3 along this bond because since these are four, these are four atoms, so C3 is not there along this axis. But if you look from this axis, can you find C3?
No, mom, I can't
No.
find it.
Yes, C3 is not there. So if you put a C3 here, this will be C3x. C3 here, then it is not there because the whole orientation will change. H down will come here. It will go like this. So C3 is also not present. Now we are left with C2. Now look for C2. So the axis notation is like this. Top is Z axis. So this will go like this. C2Z means it is not containing those H atoms. Wait, I will change the color. This H atom is there. It should go like this. In between those H atoms and B atoms. Now you have to do a 180-degree rotation. What will happen? How will it look? Suppose I will name this as B1, B2, H1, H2. And these are H1, 2, these are 3, 4, 5, 6. So it is in plane rotation. So this, suppose this is left hand side. From my side, this is left hand side and this is right hand side. in plane rotation means the left hand side goes to the right hand side and right hand side comes to the left hand side without flipping. There is no flip. So how will it look? B, H, B, H. Now since there is no other atom, this will stay, but what will happen to 1 and 2? 1 and 2 will get swapped,
Yes, ma'am.
right? And so same thing will happen to here, but there the top down geometry will not change. The top remains top, the down remains down.
Yes, ma'am.
So this is same as the given configuration. These are totally superimposable. The numbers are for our reference. It doesn't mean that you can distinguish H3 and H5. Both are hydrogen atoms only. So uh, this symmetry element is present over here. So C2Z is present. Now look for other C2, X and Y. Now I'll put C2X. So this will go like this. C2, it it contains, this axis contains both the boron atoms and nothing else. It doesn't pass through any other atom. So it will be, now in this case H2 will become H1 and vice versa, but B1 and B2 remains at their position, and the top bond will become the down bond. So H, it goes here and it goes here, around this. We don't change this dash and wedge position because we are denoting that that side is down position. So anything will, the down bond will not become an up bond. The bond, even after rotation, whatever atom will come over there will remain in the down position, right? So you don't write like B1 and just put this is wrong. You don't put like this.
Okay, ma'am.
This is wrong. The bond notations are not changing, the atoms are changing their place. So this will be H6. Now again, this is equivalent. So this also is present. Same way you can look for C2Y. C2Y is also present. Okay.
Yes,
Can you
ma'am.
do that? Just do it.
Yes, ma'am.
Just then let me know if you are not able to get it.
I can see it, ma'am.
Okay, okay. Then after C, we have found that it has a principal C axis and other two which are perpendicular to the principal axis, C2 axis. So the point group has to be D.
Yes, ma'am.
C2 axis and two perpendicular C2s. Suppose if you take Z as the principal, X and Y are the perpendicular C2s. So it is a D point group. Now we have to look for sigma planes. Now if I put a plane which contain these four atoms, this plane will be called as molecular plane. Why? Because it is
It
perpendicular
is
to
perpendicular
C2Z, which is
to
our
C,
principal
which is our
axis.
principal axis. Ma'am, I have a doubt.
Yeah.
Yeah. Uh, like we have C2 in X and Y direction also, right? Why are we not considering them as the principal axis?
You can consider them
You
as
can
principal
consider them
axis.
as principal.
The
And
principal
the
axis
principal
should have the maximum
can
number
have
of
the
atoms. You
maximum
can
number of
consider
atoms.
that.
So you can
Or the
consider that.
principal
Or
axis
the
should be
principal
the
axis
unique
should be
axis.
the unique axis. Unique axis.
Yeah, unique means it
Yeah,
should be
unique means
different
it
from
should
the
be
other.
different from the other. Ah, okay, ma'am, fine.
You can consider this also as the principal, but you will find that if I consider this, then this will not be a sigma plane.
Yes,
Sigma,
ma'am.
the definition of sigma H plane is that molecular plane is that it should contain the maximum number of elements. So maximum number of atoms.
So,
So if I consider this
if
plane as sigma, it will have the four atoms.
got it,
So
ma'am.
this will have four. Let us see whether there is any other plane which is considering more number of atoms. I think there is. This is not the molecular plane. So if you consider this plane which has, so a plane which has this, and the plane will have the B, no, it cannot be because B will be then in between. If a plane contains B, then these two bonds are not present on B, right? Again, same as suppose like you have the H2O molecule. If a plane is passing through O atom, then the H atoms are not on the plane, right? So this is same as that H2O molecule on two sides. If you consider the B atom, the plane contains the B atom, then the all the four H atoms are not in the plane. So it contains two atoms. This plane contains two atoms. So and the other plane will be like, will be containing these two H. Instead of the two borons, there will be one more plane which will contain the two, this plane. So this plane will be sigma, this plane will be sigma YZ plane. This was sigma XY, this is sigma XZ. Understood? So this also contains two atoms. That's why it cannot be a molecular plane. I have to consider sigma YZ as the molecular plane, and if I consider this as a molecular plane, the perpendicular to this will be perpendicular C2 will be C2Z.
Yes.
So this one is the principal axis. Now, okay, so we were talking about planes. So these planes, all of these planes are present over here. You can do the
You can
reflection. All the planes are present.
all the planes are
So it
present.
has,
So
as of
as
now, E, because in the last class I told you any molecule will have the identity element present. E is always present.
is
E,
always present.
then C2Z as the principal, C2X, C2Y, sigma XY, sigma YZ, sigma XZ. These are present. And what else? Any S? S is not present because because the point group has to be D. Now look for identity. If here is the identity, you look, every opposite elements are equidistant and same.
Yes, ma'am.
This is, sorry, I'll use a different color. This edge and this edge. This it is equidistant, same as the other two. This and this. So I is also present. So this makes it as D2H point group. So what was the question? So we have ruled out B2H6 as well, no S6. Now it has to be SF3. Let us see how. SF6, sorry. What is the structure for SF6?
Octahedron.
Okay. If you will see it from one of the sides, you will find it as two triangles
Yes, ma'am.
like this. So this is top and the single one is bottom. Suppose I am giving it name F1, F2, F3. This is F4, F5, F6, F6, F6. Now try doing C6. So C has to pass through it like this. C2, sorry, C6Z. If you do that, you will again get the same configuration. The top and bottom will
Yes.
not
The
change.
top and bottom.
So the dark bonds will remain dark. Now, I'm first looking at these dark bonds. So I have done a C6 rotation. So F6 should come here, F5 and F4 should come here. C6, C6 clockwise. Then F1, F2, F3. Okay. Now if you do a, so it was C2Z. Now you have to do sigma XY perpendicular. You will find that if you do sigma XY, So this dark red will go down and I will draw this with the other one. This will come up, this one. But does it make any change? Because all are F atom only.
There is no change.
There is no change. F3, F1. I'm just naming it like we are just naming it for our convenience, but we cannot identify between F2 and F4. So these are identical configurations, equivalent configurations. We are not able to distinguish whether some symmetry operation has been done. So S6 is present over here.
Yes, ma'am.
For an octahedron, so I'm coming to the next question. For an octahedron, the number of C3 excesses are. Sorry. You check it through this. You can play around with this website. It's very nice.
Okay, ma'am.
Now, octahedron. So this is an octahedron molecule. Now number of C3 excesses. Let us see. Like it will pass through the triangular faces. Opposite triangular faces.
Opposite triangular face.
So how many pairs of opposite triangular faces you can find? That many C3 is there. One,
Okay.
one, and from bottom, two. No, like from the top only you see this face, this face. Wait, I will take a screenshot and show you. Let us just show one face. See, you have this triangular face, right? This is the top side of the molecule. Bottom side is down here, which you imagine you are not seeing. So it's like square pyramidal. Two square pyramidal
Two square pyramidal.
things merged like a prism. So you have four triangular faces. One, two, three, four. So around that four triangular faces, you will have four C3s passing through the center of the triangle. Okay? Yeah. So that is it. So it has four C3s. Now do it for this one, the point group of this.
Ma'am, we can consider just like a tetrahedron, right?
Yes.
Yes.
It is a tetrahedron, but it is slightly tricky because all the cobalt atoms are connected. So, and 1, 2, 3, 4. So, all of them are connected. If you look through this cobalt, it is connected to all other three. So, suppose this cobalt which I have drawn in red is the cobalt in the center, this one. Okay, so it is connected to all other three, and the all other three atoms are also connected to each other.
Yes, ma'am.
So it's like this. It's a different tetra. It's not a tetrahedron exactly. Now, if you do a C4 and all the four atoms are connected to a five-membered ring. Okay, so if I do a C4 rotation, uh, huh, if I do a C4 rotation, I will not get the same configuration. Will I? I will get a same configuration, but a C2 will not produce it. C2 will be like this. Can you see this molecule? It is quite complicated, but it is similar to this.
Okay, ma'am.
So you have, so here it is a five-membered ring connected, right? It is showing five bonds, but just imagine that instead of these five bonds, you are having a single bond. So instead of 1, 2, 3, 4, 5 bonds, you just imagine that this five-membered ring is directly connected like this. Okay.
Okay, ma'am.
Then same way to the other. Now you have one cobalt atom, this one, connected to other three. See, this cobalt atom is connected to other three, and those are also interconnected. Okay, it is the same molecule, it's not the different one, it's the same molecule in question. Next, look for C2 first of all. Do we have a C2? It is passing through in between. Like if you have two cobalt atoms on the diagonal, it is passing through like this. One, two, three, four. So if I put a C2 over here, C2 is passing through this. Then it will get interchanged. So C2 is there. Then look for perpendicular C2s. Can we have C4 here? Is C4 present?
C4 present? Yes, ma'am.
Yes,
People
because
see.
it is very
Because
symmetrical.
very
And
simple.
instead of C2, if you put a C4 here, this thing will come over here, this will go there, this will go there, this will go there. So C4 is present. If C4 is principal axis, do we have two C2s? C2Z is present, we have to look for C2X and C2Y. To if they are present, then the point group will be D point group. If they are not present, the point group can be C or S point group. Understood? Now look for
Now look for.
C2X and C2Y.
Ma'am, in C2X and C2Y, the configuration of benzene will change, right?
Yes,
The
the up.
darkened part.
Yes,
The up.
it will get changed.
Will get.
If you have, suppose this is C2, C4, instead this is C4, then if you, wait, I'll show S4. So the, instead of this plane, imagine that it is C2X or C2Y axis. So it is not perfectly top and bottom. Can you see that? This side, if it is, so this side, if this is an axis, right? This side is towards me and this side is away from me.
Yes, ma'am.
But if you look completely down, this side is away from me and this side is towards me.
Yes, ma'am.
Then how they are This is showing S4 sigma V. 90-degree rotation and then reflection. S4 is present. So C4 is C2 Y and X is not present here.
Okay, ma'am.
So it cannot be a D group. Now we have to look for C2, C2H, S and yeah, this is not there. Now look for planes, molecular. Now, since we saw that C4 is present, since C4 is the principal axis, the point group cannot start with 2. Like here, it C2H means C2 is the principal axis, C2V means C2 is the principal axis. But here we have C4 as the principal axis. So you can rule out the other options like this, and simply you can say that the S4 is the point group. But to visualize what I just showed you in this animation, this is how the S4 will come. C4 means 90-degree rotation. So this part 90-degree rotation means this group will come over here at this location. This group will go over there at behind this location. And then if you will reflect, this will come align with this and this will align with this.
Okay, ma'am.
See, you see the animation. Understood?
Understood? Yes, ma'am.
So it has S4. Now next question is conversion of boron trifluoride to tetrafluoroborate accompanies what? Can you answer this, Navya?
And planar molecules have the highest symmetry, right?
Planar, yeah,
Planar,
they
yeah,
are more
they
symmetrical.
are more symmetrical. Okay.
But it's not that they have the highest symmetry.
Okay, ma'am.
So more symmetrical structures are octahedral, tetrahedral, icosahedral, like that. After that it comes to C infinity V or D infinity H. So from BF3 to BF4 minus, what happens? What is the point group of BF3?
Ma'am, is it C? No, D3H.
Yeah, it is T3H.
D3H.
And how does BF4 look like?
It's a tetrahedron.
It's a kind of tetrahedral
It's kind
structure.
of
So it is tetrahedral. So what is happening is the asymmetry is increasing, right?
increasing, right?
Number of symmetry elements in D3H is 12. 3 into 4. For D elements, you do to find the order means the number of symmetry elements. For D group, you multiply it with the number of principal axes and you multiply it with 4. For C group, number of principal X's you multiplied with 2. For tetrahedral, the order is 24. For D3H, it will be 3 into 4, 12. So, number of symmetry elements has increased here.
Okay, ma'am.
Okay, so all of these options you will have increase in symmetry. As you can also visualize, no, a tetrahedral thing looks more symmetric than a D3H molecule, which is planar.
Yes, ma'am.
And apart from this, bond elongation or bond contraction. Bond, now this is just a basic chemistry that when the BF3 molecule is formed, this boron atom is electron deficient. So there is a back bonding which happens from here to the unoccupied p orbital. This is the unhybridized p orbital. So it will have a double bond kind of character, and double bond will be shorter than a complete single bond. Okay, but here when F minus is there, so this back bonding thing is not required anymore because the p orbital gets filled. 2s 2p, boron is 5, 1s2 2s2 2p1, 2s2, so it will be like this. For hybridization, what will happen? Like this, 1s and 2p orbital, it will get sp2 hybridized. But when this F minus is coming, the unpaired, the lone pair of electron, the extra electron are going over here. So this vacancy is not there anymore. So these bonds are pure sp2 bonds, which are single bonds. Uh, Compared to in BF3, it has slightly double bond character. Like the electron density is more over here, so bond contracts. So the bond length is less here. Lesser bond length. So from going from BF3 on going from BF3 to BF4, the symmetry increases and the bond is getting elongated. So the first one is the correct answer. The number of C2 excesses in CCl4. What is
Is
the
it
symmetry?
true? And CCl4 is tetrahedral, right?
Yeah, tetrahedral. The same as CH4. So in tetrahedral, how many symmetry elements are there? C2s are there. Tetrahedral. So these white atoms are, suppose your Cl atoms or H atom, does not matter. Now C2, where does it go from? The planes, where does the plane go? The plane were going from, C3 planes were containing the planes were containing two bonds. But these C2 atoms are in between two bonds. Like you can imagine, if this is a bond, the C2 atoms are bisecting them. Okay, but how many bonds are there? Pairs of bond. 4C2, like permutation combination 4C2. 4C2 is what? 6. But here the axis between the top one and the bottom one is the same axis, right? You cannot count it as 2. See this one. If I'm talking about these two bonds, this axis is bisecting it, right? This is C2. But what about this bond? Again, this bond is getting bisected by the same C2, right? So if I do 4C2, which is 6, but for two pairs it is the same C2 axis, so I will have to divide it by 2, so we have 3 C2 axis.
Okay, ma'am.
Okay, so the answer is 3 C2 axis. This one you should do the point groups of these two. Sorry. They are
Ma'am,
staggered. The
what
rings are
is
perpendicular to each other.
yes, ma'am. I'm not able to see a sigma edge here.
Yeah, it's not
Okay.
there.
Okay.
Because had it been same groups here, instead of this it had been BR, you could have said that there is a sigma edge, but it's not there.
Okay, ma'am. So it's option D then. Last one.
C2, right? Okay, so you are able to do this. The other one, can you do that?
Ma'am, what does the dash bond mean? Like, it's on the plane or what?
Dashboard means it's behind.
Okay, the same thing. Okay, fine.
Same thing. And this is, just don't forget that these two are connected. It's like one group. These two are connected and these two are connected. It's a bidentate bond.
Ma'am, like sigma h is not there because in the if we like reflect it, the dash bond is coming on top, right? That's why it's not there.
No, sigma h is not there because this bond is behind and this is front.
Because okay, ma'am, yeah, got it.
Yeah. So these two will come in the same plane. But
Yes, ma'am.
these two two are not
these
coming in a
two are not
plane. These are
coming in a
like
plane.
bidentate, so these are angled like
These
that.
are acting like that. Yes, ma'am.
And they will not even reflect from the top.
Got it, ma'am.
Okay, so here I have few molecules. You can just take a screenshot out of it and try doing it yourself. You can ask me in the next class if you are not able to find it.
Okay, ma'am.
Yeah, simply take a screenshot, or you can just watch the YouTube video later. Okay, so now you can
Yes,
submit the
sir. Now you
assignments,
can.
right? You have already submitted,
I
you
have
said.
already submitted you, sir. Yes, ma'am.
Fine. Are you watching the lectures now, Fa?
Yes, ma'am. I'm watching it.
Okay.
Okay.
Okay, then I'll
Screenshot.
close today's sessions. Or do
Today's
you have
sessions.
any doubts?
No, ma'am. It's okay. It's fine.
Okay.
Okay. Thank you, ma'am. Good
Okay,
night.
thank you. Thank you for
Bye.
joining.
Thank you for joining. Thank you, ma'am.